Thanks, Jens. And good afternoon, everyone. Thanks for coming to this. Really excited today to be sharing this I'm going to say it again, exciting analysis that we've been doing about where Vermont's conserved lands are and how they contribute to ecological function. And then from that analysis, what sorts of things we can look into the future and think about for land conservation in Vermont. Just before launching into the presentation here, just a few helpful reminders if you're not familiar with Teams. There's a bar that has all of the different controls for you. There's the chat, and we're asking that if you have questions, please put those into the chat. The raise hand function, which I think we may not need today, but Jens, correct me if I'm wrong. And then there might be a moment where we are using cameras and mics, but for this part, please keep yourself muted. Just if you want to practice with the chat function, it would be great if you could introduce yourself in the chat, your name, your town, your organization. And again, if you have a comment or question, you can put that in there at any time. And Jens and my colleague Dave Maroney are monitoring that chat to help this flow. So just to get started, really at the basics here, like Jens, I'm part of the Vermont Fish and Wildlife Department, and the mission of the Fish and Wildlife Department is the conservation of our fish, wildlife, plants, and their habitats for the people of Vermont. It's a broad mission. There are something like an estimated 20 to 40,000 different species in Vermont, and it's the charge of the department to think about how to conserve all of these species. The work that I do is typically at the large scale, and a lot of that intersects land conservation and land protection, permanent protection of important natural areas. We're going to be working through a couple of different segments in this presentation. We're going to start with some context setting, talking about Act 59, which is Vermont's Community Resilience and Biodiversity Protection Act that was passed in 2023. And then we're going to relate that to Vermont Conservation Design. We're going to talk about the pieces of Vermont Conservation Design and how those pieces of the design intersect with the conserved lands we have in the state. We'll be taking a couple of breaks for questions as we're moving through each of these sections. So starting with this Act 59, the Community Resilience and Biodiversity Protection Act. This was an exciting piece of legislation that set vision and goals for conservation in Vermont. And you can see here the vision of the state of Vermont to maintain an ecologically functional landscape. The Act also set goals that Vermont would conserve 30% of its land area by 2030 and 50% of its land area by 2050. There were two main charges in the Act in support of this vision and goal, of these vision and goals. The first part was to do an inventory of conserved lands, and you can see that there, the first part. And not just to do an inventory of conserved lands, but to do it to serve as the basis for meeting the conservation goals of Vermont Conservation Design and the vision and goals that I just mentioned. The second part is the development of this conservation plan that would, based off that inventory, guide what happens, what places, what lands are most important for reaching those 30 by 30 and 50 by 50 goals. Seeing that there are people having problems seeing the slides.
Bob, just go ahead. We'll take care of it in the background.
Okay. Want to note that the Fish and Wildlife Department is part of the Agency of Natural Resources. The Agency of Natural Resources is not the lead organization on either of these tasks that I'm showing you here, the Conserved Lands Inventory and the Conserved Lands, the Conservation Plan. The Vermont Housing and Conservation Board is the lead on both of these, and they've completed the Conserved Lands Inventory. That was completed a little less than a year ago, and they're about to begin the process of working on this conservation plan. And so the work that I'm going to present today comes from this conservation inventory and might inform this conservation plan, but it is ultimately the work of the Vermont Housing and Conservation Board that is in charge of both of these efforts. So the inventory of conserved lands was released, like I said, about a little less than a year ago, and it identified where all the conserved lands are in the state, and then placed them into categories that were defined in Act 59. Ecological reserve areas and so forth there in the list. I'm going to show you definitions of those in just a second. But the big upshot of this report from the Vermont Housing and Conservation Board was that Vermont is 27% permanently protected, permanently conserved, meaning the land is either protected by ownership or easement in a way that ensures long-term legal protection of that land for conservation purposes. And when we look to the 30% goal, I think that's very exciting that we're that close. Like I said, the Act breaks down the land into these different categories. And here's some my shorthand definitions of those categories. We'll see these throughout the different analyses I'm going to present today. The main categories are ecological reserve areas, which could be thought of as places where natural processes predominate. This could be something like a natural area, a wilderness area, a wildland. Biodiversity conservation areas are places that are managed for the benefit of particular species or habitats. The management might be something like managing for grassland birds, something that's very intensive, but with a conservation focus on species and habitats. And then natural resource management areas are most conserved lands that have broad multiple uses. They might include sustainable forestry. There's a portion of the natural resource management areas that could be agricultural land. It could be recreation lands, a broad suite of uses that also protect biodiversity. So we can look at those categories and take that 27% and dig in with a little more granularity to see, well, how are the conserved lands in the state divided among those different conservation categories, those different primary purposes of the land? And here's that breakdown here. It's approximately 4%, 4%, 16, 2, and then a little bit of miscellaneous that gets us to that 27% conserved. And again, this is the work of the Vermont Housing and Conservation Board that placed the land into these categories and came up with these numbers. We took that and decided to dig in a little deeper and break this down into biophysical region analyses. Vermont has 9 biophysical regions that are defined based on differences in elevation, climate, geology, topography, vegetation. They're a large-scale proxy for the diversity, for the biological diversity of the state. And so you can see those 9 regions labeled here on this map. We can look at the distribution of conserved land around all of those biophysical regions. And that's what this chart shows here. The total area of the biophysical region in acres is the length of the bar, and the bright colors, the greens, the blues, the browns, and the orange, show the distribution of different categories of conserved land in each biophysical region. So what you can see right off the bat is that the southern Green Mountains, the northern Green Mountains, and the northeastern highlands have relatively high levels of conservation. And there are other regions like the Champlain Hills or the southern Vermont Piedmont, where there's a relatively low proportion of the area in any form of permanent conservation. On Another way to look at that is to make all the bars the same length and look at the percentage of each region that is conserved by those categories. And if we do that, it looks like this. Same basic story, but it gives us a more equalized way to compare work in the different regions. We can view this spatially like this. There's the outlines of the biophysical regions in black, and then the different types of conserved lands in those bright colors. And we can see that the Green Mountains, the spine of the Green Mountains, there's a lot of conservation, primarily because of the Green Mountain National Forest and state lands like Camel's Hump State Park and Mount Mansfield State Forest. Other regions you can see relatively less conservation. The Northeastern Highlands, the Northeast Kingdom, of course, has the Champion Lands, which is a very extensive set of conserved lands up there. This has implications for conservation of biodiversity. Different parts of the state, because of those differences in elevation, climate, geology, all of those physical factors results in different vegetation patterns, different species, different natural communities. The Green Mountains, the Northeastern Highlands, have lots of high elevation forest, spruce fir forests, the places many of us love to go hiking. And our conserved lands reflect those types of forests really well. Our conserved lands do not reflect lower elevation settings like valleys, mid-elevation hills, places where you might find oak forests, hemlock forests, a very different suite of species associated with those types of forests and other natural communities common in those regions. And so by looking at where our conserved lands are and the type of lands that are protected for the long term, we can say we've protected those high elevation settings very well, but we have not done a lot to protect those lower elevation settings, natural communities, and species. And so I think this tells us something about our past work representing across all the biophysical regions and some ways that we might be able to think about how we could incorporate that representation into future conservation work. And while it wasn't a point of the analysis, I will just mention that distribution across all biophysical regions is really also a social benefit for providing people access to conserved lands and nature and all the benefits that come with that. This is a chance for some questions. Jens, Dave, do we have questions in the chat?
Yeah, thanks so much, Bob. So as Bob mentioned, folks, first off, hi, I'm Dave Maroney, helping to support this webinar in the background. And as Bob mentioned, we'll have a couple of these breaks for questions. But I want to encourage you that really any time throughout the presentation, you can type a question or a comment into the chat, and I will be watching and monitoring those, and I can read them back to Bob so they can get answered during these sections because we have quite a long guest list. But let's take this opportunity. I see we actually have one raised hand. Diane, if you'd like to ask your question, please go ahead.
Yeah, thanks. I tried to, can you hear me?
Yep, I can hear you. Great.
Okay.
Thanks.
I tried to put it in the chat, but my chat's not working. But when you go back, Bob, to the that bar chart that goes sort of lengthwise across the screen, there are the colors, and then there was all that gray space. What was the gray representing?
Thanks for asking that. The gray space would represent the remainder of the region, or you could think of that as all the lands that are not conserved in that region.
Okay, got it.
So
got it. That was
here we're seeing that as a percentage of the region. The other bar showed it as the raw size.
Got it. Okay, thanks.
Perfect. Thank you so much, Dan. And yeah, it looks like we're having a couple little tech difficulties. So sorry about that, folks. Chat not working for a couple people, the presentation not working for a couple people. So we do apologize for that. I do want to mention that this will be recorded. So if anyone has any issues accessing the presentation, you'll definitely be able to see it at some point, and we'll try to get this sorted out by next time. With that, one more question for you, Bob, and then we'll jump into the next section. Can you please say a little bit more about why all the agricultural fields are categorized as conserved. That's our question. So this it looks like Katie is noticing that some of those agricultural segments are included in that 27% that was conserved in that figure. And can you say anything about that?
That's correct. So those are conserved. Those are, as I understand it, those are agricultural lands that are permanently conserved against conversion to development. Some of those, I'm not sure if they're all permanently conserved only for agriculture or to be maintained in agricultural or forest condition. The details of that were part of the work done by the Vermont Housing and Conservation Board. I think maybe if we haven't already, the link to that report will be in the chat, and that's really the place to go to for the information about that.
Great, thanks, Bob. And Katie, yeah, it's not all agricultural fields, just a subset that have conservation easements there. So, all right, Bob, let's jump right back in. Great questions. Thank you, folks. Keep them coming, and we'll get another chance to answer them soon.
Great. So that was that sort of broad look at the initial conserved lands inventory prepared by the VHCB. So now what we want to do is to think about overlaying that distribution of conserved lands with the Vermont Conservation Design. And Vermont Conservation Design is our vision for what it's going to take to sustain the state's natural areas, forests, waters, wildlife, plants into the future. It's really a vision to maintain nature and all the benefits it provides. It's a prioritization that shows the places that are most important for maintaining ecological function. And if you want to see Vermont Conservation Design, if you haven't already, you can dig into it on the BioFinder website. It's an interactive map where you can look at any part of this in great detail, zoom in and out. There is the overall map of Vermont Conservation Design that you see behind the words there. Without going into great detail about it, there are many components that stack up to identify all of the highest priority pieces of this design. And so the slide here shows the different landscape components that stack together to make the broad scale of Vermont Conservation Design. Vermont Conservation Design is based on all of the pieces coming together, all of these things contributing to ecological function. It's not a buffet where you can take only one piece. And so it's important that we have the functions of all of the components. Now, of course, you're probably thinking and noticing that the design identifies a large portion of the state as highest priority, and it sure does. I think it's something like 70%. Obviously, I think it's obvious, at least in our current framework, that we're not going to be maintaining all of that 70% through permanent land conservation. That's not all going to be purchased or placed under conservation easement. There's a whole variety of tools that can be used to achieve the goals of Vermont Conservation Design. Permanent land conservation being just one of them. So just really want to stress that as we're looking at this, the goal here is not to get all of Vermont Conservation Design permanently protected, but to use permanent land conservation in the right places. So I want to dig into a key part of Vermont Conservation Design, which is forest blocks, these intact units of forest and other natural cover. You can think of them being bounded by roads, development, agriculture. If we just look at the past conservation work that's been done and how much of that overlaps the highest priority forest blocks identified in Vermont Conservation Design, the overwhelming majority of past conservation work in Vermont supports the conservation design. And I think this is just an amazing success that so much of our conserved lands are supporting these highest priority places, ensuring that those functions can be maintained into the future. So you can see there all those categories well above 85%. And of course, when you include agricultural land, just by definition, it can't support forest blocks. It's a different type of conservation. So we don't expect that to be overlapping a forest block. But the areas that are conserved of forests and other natural land, the vast majority of that is supporting Vermont Conservation Design. We can look at that in a similar bar graph like we looked at with the biophysical regions. only now we're not looking at the region as a whole, but just the highest priority forest blocks in each region. And we see a pretty similar pattern to what we saw with the overall region. The Green Mountains and the Northeast Highlands by far have the most conservation work done. This has some striking spatial patterns. So here's the area around Montpelier, and this is showing in the gray and the other colors the extent of highest priority forest blocks. And the gray is the unconserved land within those forest blocks. The other colors are the conservation categories, the permanently conserved land within those blocks. And so we're looking at Montpelier in the center there, more or less, and then Camel Sump and Mansfield on the north and south of I-89. Slightly to just to the north of Montpelier is the Worcester Range. And then over to the right side of the screen in brown is Groton State Forest. A lot of conserved land in those forest blocks, really starting to put together a pattern of conserved lands that allows species to have intact areas and also connections between those intact areas. It's a very different story if we look at the area around Brattleboro. So here again, the highest priority forest blocks and the conserved lands within those blocks, not a cohesive pattern of connected core areas and connections, but more of a scattershot of conserved lands. So this is a region with a much lower level of conservation relative to the area. And I just highlighted here the Vernon Town Forest down there in the lower right. Also, right next to it is in blue, the Roaring Brook Wildlife Management Area. But an example of how town lands are contributing to maintaining ecological function in that larger pattern of forest blocks. Within those forest blocks, we can look at them through a couple of different lenses. And one is to think about the interior forests, the big intact core areas of forest. And then the connectivity blocks, the stepping stones, small blocks that are priority because they're the little bridges between the big blocks. By themselves, they might not be necessarily that critical, but it's their spatial location, their role as that stepping stone that makes them critical, because there are little patches of forest that connect these blocks, or riparian pathways that also connect these blocks. These stepping stone blocks, which I'm now showing here in orange, in contrast to the big interior forest blocks shown in purple. These smaller stepping stone blocks, if we look at the rate of conservation in them, we see that it's much lower across all the biophysical regions. So if we look back, we can say we've done a really good job protecting these large intact forest blocks, but we've not done as much work collectively conserving the stepping stones that are key for the ecological connectivity between these blocks. That connectivity is essential both for individual animals moving around to meet their life needs, like bear and moose and lynx, species that range widely, but also for long-term genetic flow that's critical to maintaining healthy populations, and the long-term redistribution of species range movements in response to climate change and other threats. Species need to be able to shift across the landscape. Maintaining that connectivity is essential. We know that when there's focused conservation work on a connectivity corridor, great things can happen. And this is a story from our department, but with many, many partners, including the Mount Holly Conservation Trust. About 40 years ago, department staff, particularly Kim Royer, who's shown here, identified the corridor between Coolidge State Forest, which is the state forest next to where Killington is, down into the Green Mountain National Forest, the White Rocks Recreation Area, that area in the southern Green Mountains was a key connectivity corridor, and that without that, bears would be very constrained in their movements up north and south through the state. So that effort, which began 40 years ago to conserve land in that corridor, has just recently, in the past couple of years, resulted in a complete connected corridor of conserved lands from the Green Mountain National Forest all the way up to Coolidge State Forest, where there is conserved land to conserved land to conserved land to maintain that ecological connectivity. And the Mount Holly Conservation Trust was critical in the acquisition of one of the last corridors, or the last parcels to complete that corridor. In this work, we've been looking if we can identify, well, there's one corridor, that bear corridor. What would be other corridors that might be priorities for land conservation into the future? And here's a map showing some of the places that pop because of the importance, the regional importance of the connection, and also the relatively low level of land conservation in the stepping stones through that corridor. So you might look at some of those large blocks and say, yes, those have a lot of conserved land, and that's true. But it's getting from those conserved lands to the edge where they are adjacent to another block and then stepping stone along until you get to the next big block. So thinking about how those corridors could be maintained through permanent land conservation. Okay, time for another break and questions.
All right, thank you so much, Bob. All right, folks, time to pick your brains. If you have questions, feel free to enter those into chat now. But we do have one great question for you from Mike Maloney, Bob. Mike is thinking about zooming in a little bit closer to a town-wide scale. A lot of developments have common land, which is land that is a no-build zone or has been put into open space protections at a town scale. That's shared access typically between development residents. How is that land classified, or is it in terms of this analysis? Is common land at a town scale really included in this analysis?
Good question. I would say that land is not in this analysis. I think there's a good argument, perhaps, that those lands do meet some definition of permanently conserved if they have that long-term protection legally built in. Part of the challenge in this is just getting the data and understanding where all those places are. And the Conserved Lands Inventory was about a year-long effort, and it had to rely on the best available data that could be gathered during that time frame. So I'm not aware of any effort to try to get all of those sorts of parcels. And I think there's many sorts of lands like that, not just that, but other similar situations like permit requirements and other small pieces of land. And trying to fit that in would be awesome. I think it's going to be another step and another analysis, but yeah, I think that would be so neat to look at that.
Thanks for pointing that out, Mike. And kind of building off that, we had another question that came in, which is, how do town forests enter into that calculation, Bob?
The town forests were all included in that Conserved Lands Inventory by VHCB, so long as they were there was data available on the extent of them. And I'm guessing we got everything, they got everything. I don't know that for sure, but I know that there were many, many town forests, like the Vernon Town Forest, that were included in that data set.
And I do know that there's an independent inventory that's ongoing right now in collaboration with the University of Vermont researcher that's seeking to sort of make a complete inventory of all the town forests across the state, including smaller parcels that maybe haven't been previously inventoried or mapped on that. Great, let's take time for two more questions.
Can I just add on that quickly that the law also, the act requires that the Conserved Lands Inventory be updated every 2 years. So as this new information comes in, it can be incorporated into this. And my hope for sure is that the data set just improves and improves over time, and we continue to just have a much better window into how all these lands contribute to ecological function.
Let's go to Diane. Diane, I know the chat isn't working for you, so I see you've got your hand up again.
Yeah, two quick questions. I've read that there's more biodiversity at lower levels of elevation than higher. I just want to confirm that.
As a general rule, I think that's a safe statement. There's all sorts of nuance in there for sure. I think one of the things is that it's not just about more or less biodiversity in particular places, although that sure matters, but it's about representing all of the biodiversity. There might be more in some places like lower elevations, and we want to make sure that is maintained into the future. And for sure, we also want to maintain places that might be higher elevation or have fewer species. It's not that those are less important. We just want to make sure that to maintain large-scale ecological function, we need all the parts wherever they are. And so, yeah, it's absolutely the case that that lower elevations, certain geologies like limestone bedrock tend to have more species diversity. But I think I really come back to this idea of we'd like to maintain it all. We want to maintain what we have, all of it into the future.
Right. And I think that's great. It just seems like the higher elevations are getting a lot of protection and the lower elevations it's harder to protect. Now, my second question is, in current use, isn't there, I know you can put ag land and forest land in current use, but isn't there now a way to put ecologically special areas in current use?
Yeah, there is. There's a couple of categories in current use that focus on ecological protection. Those wouldn't necessarily be considered permanent because you can remove land from current use. You can change those categories. But current use is such a key tool in addition to everything we're talking about today. And so just really briefly, I'll mention that there are ecologically significant treatment areas where you can enroll rare species habitat, significant natural communities. There's significant wildlife habitat in the use value program. And there's also the new reserve forest land category where you can manage for old forest conditions in UVA. And we need a whole separate webinar to cover all the details on those, but they are key ways to maintain ecological function.
And so current use program lands would not be included in conserve. Okay, that's what I thought.
Considered here. They'd add a whole other roughly 30%, I think, to the map if we put all those lands that are in current use but not otherwise conserved.
Wow, great. Okay.
So together, these two things are super powerful.
Thank you, Dan. Thank you, Bob. Yeah, that's a great example of how permanent land conservation is just a part of the story and how we get to this ecologically functional landscape. All right, let's take time for one more quick question, and then we'll move on to the next section. And Bob, this is from Jennifer. The question is, how much might Vermont's ravines potentially serve as part of the stepping stone system's interconnectedness? So in other words, can a narrow, steep ravine, can that be an effective way for animals to, stepping stone through the landscape?
Yes, but part of the question, I guess, is for what species? When we're thinking about all of the species, something like an oak tree. Can a blue jay pick up an acorn and fly across the ravine and drop the acorn? Like, absolutely. And that's a form of connectivity, and having that close connection can be really important. Bobcat and lynx will probably go right across anything. Can a salamander cross a steep ravine? Could a salamander get across Smuggler's Notch? Probably not. So there's a lot of nuance to that. But I think it's one of the reasons that redundancy and connectivity is so important, so that we can't one by one assess the needs of every particular species. But if we have redundancy in pathways and options for species, we can have some confidence that they will find at least some way to get where they need to go.
All right. Thanks so much, everyone. Let's jump into the next section and we'll have more opportunities to come.
All right, let's shift away from forest blocks for a moment and talk about surface waters and riparian areas. Vermont Conservation Design identifies the complete network of lakes, ponds, rivers, streams, and their vegetated margins, and really the whole valley bottom setting that they occur in as highest priority for ecological function. This does all sorts of things to protect biological diversity and has all these other benefits like flood protection that are just incredibly important benefits to people. Water itself, and this is a really, I think, key point, water itself is a public trust managed by the state. And so water can't be owned the way that land is. So we don't really consider the water itself when we're talking about land conservation, but we can think about the riparian area adjacent to that water, which in some places might be very narrow along a small stream or along a larger river. That floodplain, that valley bottom setting might be much, much larger. We can look at the rate of conservation in those riparian areas across the different biophysical regions. So this is a similar chart to what we've seen before, but now we're looking at just the land conservation within riparian areas in those regions. So now we see a slightly different pattern where still the Green Mountains and the Northeast Highlands for sure have lots of conservation. But now actually we see the Champlain Valley, there's been a lot of conservation, or relatively more conservation done close to water than across the region as a whole. We also see now that there's agricultural land supporting these riparian areas. And I think it's important to keep in mind that this analysis is just looking at the category of conserved land. It doesn't really get to the granularity of understanding what's happening in that 50-foot buffer, what's happening in that 100-foot buffer right off the water. We don't know that on any of these categories for sure, how these lands precisely are contributing to the functions of these riparian areas. But we do know that across all these categories, they are places that have conservation intent and the oversight of either a conservation organization like Vermont Land Trust or the Nature Conservancy, or an agency like the Forest Service or Vermont Fish and Wildlife or Forest Parks and Recreation. So there is a conservation connection to all these places that I think is really powerful and exciting, both about maintaining what we have and when it comes to opportunities to restore riparian areas. Another way to look at that is to look at small watersheds. And again, looking at the conservation within riparian areas, which watersheds have more than 30% of their riparian areas conserved? And so we can see this here. It's a very different map, not focused just on the Green Mountains, but highlights some other areas where there's been a lot of work along riparian areas in different parts of the state. If you're having a hard time visualizing spatially what that looks like, here's an example of just showing those riparian areas and then the different types of conservation within them. So now it's these stringy bits across the landscape following the water. The gray is the unconserved portions. The colors are the conserved portions. So this is the Liebrook Wilderness outside of Manchester, part of the Green Mountain National Forest, where all of this headwater area is conserved as wilderness, so it fits into that ecological reserve category. If we look up near Swanton and Highgate, we can see, again, the riparian areas here along the Missisquoi, and we can see the different pattern. And here's a place where different types of land are contributing to that conservation, and where agricultural lands, conserved agricultural lands, might provide an opportunity to look at what sorts of contributions to riparian function are occurring in those different places. I think a key theme here is that riparian conservation is partly about the quantity of land conserved, but we know that riparian function is so closely tied to the type of vegetation along a waterway, to the type of physical processes, like can the river use its floodplain the way that it naturally would. There are so many other elements that have to be brought into thinking about the conservation of riparian areas and aquatic function, that it's really not just quantity, it's also about quality. And this is not a data set that lets us get at that quality question. There's a whole other angle of work there to really understand what these conserved lands can do, have done, and can be in the future. Shifting gears back to forests and to a very different part of Vermont conservation design. The design lays out these broad landscape areas, but it also lays out some goals, some targets for the structure of the forest within these broad areas, and sets goals to really bring back young forest and old forest into the mix on our landscape. Because of Vermont's land use history, we don't have much old forest. Most of it has at some point been cleared or at least harvested. And so the trees are relatively young or middle-aged, which for a tree could be 80 to 90 or even 100 years old. We also don't have much young forest, the dense regenerating forests that are so critical for so many species of wildlife. Vermont Conservation Design sets these goals to bring in the edges and really diversify the overall structure of the forest. And I just want to talk a little bit about old forest because I think they're just naturally engaging places, but they're also ecologically really important. Here's just some definitions of old forests, some of the characteristics of old forests. These are not old growth. It doesn't have to be places that have totally escaped human influence, but they are places where forests have gotten old. They have had minimal human interference for a long time, generally 150 years at least. And they display this really complex structure. And because of that structure, they support so many species. There are so many niches for species to find habitat. A key strategy for developing old forests and protecting old forests in the long term is this idea of establishing ecological reserves, places that allow or that focus primarily on just natural processes with minimal human interference. So I just want to dig into that category and how it relates to the old forest targets in Vermont Conservation Design. And I want to be clear, there's other ways you can get old forest besides establishing ecological reserves. And so I'm not digging into all that because it's separate from this question of land conservation, but just want to acknowledge that's out there. If we look at the forest in each biophysical region, and we look at the goal for future old forests in Vermont Conservation Design, and then the area of ecological reserve, we can have one metric for looking at how might we be making progress towards eventually reaching those old forest goals, recognizing that the forest still has to actually be old and most of our forests are not. So this chart shows the full amount of forest in each region, the VCD old forest target, which is the combination of the dark green and light green, and then the area of ecological reserves in each region in the dark green. And so you can see there's been a lot of work in the northern and southern Green Mountains, relatively less in other biophysical regions. That focus on the northern and southern Green Mountains means that the types of forests that we have represented in ecological reserves are not representative of Vermont's forests broadly, for the reasons that we've kind of talked about, that if you're only focusing on certain biophysical regions, you're only representing certain types of the forest and the species. And so what these charts show across the top is the balance, the sort of percentages of different forest types in ecological reserve areas across the state. The bottom bar is that same balance, but across, if you look at the state as a whole. And so what this is showing is that dark green montane spruce fir forest is 2.2% of Vermont's forest overall, but it's 15% of the forests that are protected as ecological reserves. That orange hemlock oak forests found at low elevation is almost 30% of Vermont's forest overall, but just 5.4% of the forest protected as ecological reserves. And so as we look to the future, trying to get that ecological balance would mean maybe we need to focus less on the high elevations and more on the low elevations to try to bring that into a little more balance. We have data. This is just to give you a sense that we can map out where these different forest types are. And I don't really want to get into all the details here, but the colors represent the different forest types. And that orange, the hemlock forest that I was just showing you in the previous graph, now it's being shown in these two colors, the blue-green and the brown-pink. And if we look at where that is in the southern part of the state, it's kind of in these red areas. And I just want to make the point that if we look at those red areas, and then I've chopped out everything except the Green Mountain National Forest. So those greens and purples, that's the Green Mountain National Forest. And the point here is that if we want to get ecological representation, it's not in places that might be conserved now. We can't just change the status of some of our conserved lands from one category to ecological reserve and expect to get that full ecological representation that I was just trying to show. The forests, the places we need are elsewhere. And I think it's new conservation work, a combination of probably all sorts of types of conservation, nonprofit, public lands, et cetera, that's going to get us eventually to that future old forest goal. It's been a long time since we looked at a pretty picture in this presentation. So here's Bourne Pond and the Wybrook Wilderness, an example of those ecological reserve areas. So that was the whirlwind tour through these analyses and some of the outcomes from that. And I think we have more time for questions, right, Dave?
Absolutely. Yeah, so we're going to end with an opportunity for Q&A here. And so this is your opportunity to ask any of those burning questions. And we'll go to the chat to start out here. So Bob, as you were talking about how nonprofits and public conservation is going to be important, our question here actually asks about public versus private. So the question is, sort of two-part. First off, does the VHCB report give a breakdown of public land versus privately owned conserved land? And then second, kind of what is that role for private landowners in terms of conserved land that's being held in private ownership? What's the role of that in attaining 30 by 30 and 50 by 50 goals?
Those are great questions. I'm not sure if that VHCB report breaks down public versus private land. It might not. And I don't know those numbers off the top of my head either. And I'm going to restrain myself.
I'm not going to restrain myself.
Go for it.
We're at about 17% public land. So the state of Vermont owns about 8%, 9%, and the feds are also in that 8 to 9% range.
Okay, that sounds plausible. That would be a great question to dig into, and there's all sorts of granularity that could come out of that, I'm sure. And probably we'd see differences in that balance across the different biophysical regions. The role of private landowners, of course, any private land that's conserved through an easement or an acquisition, that's all based on willing landowners. So it's choices that landowners make. And I think the choice to permanently conserve land is a powerful one and one that really has a long-lasting impact. But I think there's a whole range of choices that landowners can make to contribute to ecological function. And I think so many landowners are choosing to do that in Vermont. I think we see that with current use, with the interest in managing land well. The ones that are the lands that are permanently protected, those landowners have the benefit of a relationship with a conservation organization, access to information and resources. I'm not sure if I'm answering your question, but I think there's a whole range of strategies that they can be doing that is supporting this idea of maintaining ecological function.
Great, thank you, Bob, and thank you, Diana, for that question. All right, so let's go back to, I see we have a hand raised, and is Diane again. Diane, go ahead.
Sorry. Bob, do you know when the next phase of the 30 by 30 reporting is going to come out? When's the next report? And I think it's going to be interesting. It'll be the plan part, how we're going to get to 30, right?
I believe that is the very end of this year. If it goes on schedule, I believe that's due something like December 31st, 2025.
Okay,
and
thanks.
I'm not certain what the process will be to get from where we are now, with that inventory report. I mean, this is all VHCB's work, so it's not really mine to talk about, but I mean, I'm not sure what that process will look like yet.
Great, thank you. So we still have a couple minutes here for questions, but Bob or Jens, if any of you have any sort of closing thoughts or parting wisdom you'd like to leave us with as we kind of wind down and wrap up our webinar here.
Yeah, I think being able to dig into this has been, for me, it's been just so, I don't know, partly inspiring to see where we're at and to see how successful we've been in the past and what these lands are already doing to maintain ecological function. And to think about how the combination of these tools of looking at this land inventory with Vermont Conservation Design can give us such a powerful window into how we can support ecological function into the future. And not just ecological function, because we know if we conserve Vermont's natural landscape, all the benefits that nature provides, that gives us so much more here in the state. And so it's the benefits to all of us. It's the landscape we love, the wildlife we like to see, all of that coming together, flood protection, working forests, working farms. I think seeing how ecological function can be supported to support all of that is really powerful.
Great, thank you, Bob.
Dave, if I may just jump in, regarding Diana's question about the 30 by 30 and the 50 by 50, I'll just, in Act 59, in the law, 30 by 30 has to be attained only through permanent land protection. The 50 by 50, they leave the door open to other types of conservation that are quote unquote measurable and enforceable. And the inventory didn't spell out what those other types of conservation might be. So there's a bit of ambiguity in terms of what types of conservation might be involved in the 50 by 50 goal. But to your point about the role of private landowners, I think it's very likely that the use value appraisal program current use would be considered measurable and enforceable in terms of helping us to reach that 50 by 50 goal. I can't, it's not up to me, but I think that would be likely. I'd also suggest that municipal land use policies would also be considered measurable and enforceable. And so the role that towns play in that 50 by 50 through their land use planning is really huge. And that's, Bob spoke a lot about pattern in the landscape. And so I really just wanted to emphasize the role that towns play through their land use policies in terms of maintaining that pattern, that ecological pattern, and contributing to that 50 by 50 goal. Thanks.
Great, thank you, Jens. All right, so I don't see any other questions coming in. A kind comment from Jennifer, thank you very much. Thank you to Bob and Jens for putting this together today. Thank you especially to Bob for presenting. And with that, we'll end actually a few minutes early. So everyone get out and enjoy the snow. And we'll see you hopefully in our virtual space for another webinar soon.
Thanks so much, Bob. Excellent.
Have a
Thanks
good one.
all.